IP65, IP67, IP69K. Those two little digits decide whether your device survives the plant floor. Get them wrong, and a sensor that worked fine on the bench dies the first time the line gets washed down. Get them right, and the same part runs for years in dust, spray, and grime. So what does an IP rating actually mean? I will explain what IP stands for and how the two-digit code works, what each digit really protects against, and how to read the common ratings on a spec sheet. By the end, IP65 versus IP67 stops being a mystery. Let us start with the code itself. Quick note before we dig in. This is from PLC Simulator, where you can practice PLC and panel skills free right in your browser. No install, no hardware. The kit that lives inside these rated enclosures. You can wire and program hands-on. The link is in the description. Click the link in the description to try it free. Now back to the code. IP stands for Ingress Protection. It is a standardized grade, defined in the IEC standard 6529 for how well an enclosure keeps things out. Not a marketing badge, an actual tested rating. And the format is simple. The letters IP, then two digits. The first digit is protection against solids and dust. The second digit is protection against water. So IP65 means a first digit of 6 and a second digit of 5. Higher numbers are better in both positions. One more thing. Sometimes you will see a letter X, like IPX7. That X means that level was not tested or not specified. IPX7 says it was rated for water, but the solids protection was left blank. Let us take the first digit, solids and dust. It runs from 0 to 6. 0 means no protection at all. 1 and 2 are about big objects, then fingers, kept out for basic safety. 3 and 4 step up to tools and wires, then most small particles. 5 is where it gets useful on a factory floor. 5 means dust protected. A limited amount of dust can get in, but not enough to stop the device working. And 6 is the top. 6 means dust tight. No dust gets in at all. So when you see a 6 in that first slot, the enclosure is fully sealed against dust. That is the level you want around grinding, cutting, or any dusty process. Now the second digit, water. This one runs from 0 all the way to 9. Low numbers cover dripping and splashing. 4 means splashing water from any direction is fine. 5 and 6 step up to low pressure and then powerful water jets. 7 means the device can be immersed, submerged in up to 1 meter of water for 30 minutes. 8 means continuous immersion with the exact depth set by the manufacturer. And then there is 9K. 9K is the toughest, high-pressure, high-temperature washdown, the kind used in food and beverage plants. Now let us decode the codes you will actually see. IP54, dust protected, handles splashing. IP65, dust tight, survives water jets. IP67, dust tight, survives a 30-minute dunk. IP68, dust tight, continuous immersion. And IP69K, dust tight, and built for high-pressure hot washdown. So why does this matter? Because the IP rating is how you choose the enclosure, the sensor, or the device for where it actually lives. Match the rating to the environment. An indoor control cabinet might only need IP54. A sensor on a dusty plant floor wants IP65. Something outdoors or near a washdown area wants IP67. And a food and beverage washdown zone needs IP69K. Overrate it and you overpay. Underrate it and it fails the first time it gets sprayed. One quick note, for North America, you'll also see NEMA ratings. As a rough guide, NEMA 4 is close to IP66, and NEMA 4X adds corrosion resistance. Close cousins, not identical. And remember, the rating you pick is the spec for the cabinet that houses your PLC and devices. I have a full electrical control panel walkthrough, linked below, that shows what goes inside it. So here's what to walk away with. An IP rating is 2 digits. The first is solids and dust, 0 to 6, where 6 is dust tight. The second is water, 0 to 9, where 9K is high-pressure hot washdown. Read both. A high water number does not promise dust protection. Match the rating to the environment and the part lasts. Get it backwards and it fails. Now, go make it concrete. If you want to practice PLC and panel skills hands-on, click the link in the description to start free at plcsimulationsoftware.com. No hardware, no install. Subscribe, new video every Tuesday. See you in the next one.